So today we're going to take a look at angles and radian measures. So up until now we've only measured angles in degrees, and today we're going to take a look at another measurement that's called radians. So, oops, can we make this? Alright, we'll deal with it blue. So what we did here is in class we took some string and we measured the length of our radius, and then we started marking off around there. So this was like 1 length, 2 length, 3, 4, 5, and 6 all the way around. And we said it takes about 6 radiuses to get all the way around the circle. And we said to get halfway around it was a little bit more than 3. And we said a number a little bit more than 3 is, oops, sorry, this ended up right about there. So it was a little bit more than, it was about pi. And so we talked a little bit about how it kind of makes sense that we're measuring this radians because 360 is just an arbitrary number, but if we measure according to the length of the radius, that makes a little bit more sense. That has to do with the circle. 1, 2, 3 radiuses and pi right there. So then we started to take a look at what exactly is a radian. So it's a measurement in terms of the radius length. And one thing here is we said 180 degrees equals pi radians. So if we want to know exactly what 1 radian is, 180 over pi equals 1 radian. And if we divide that out to see what it is as a decimal, that is approximately 57.3 degrees is equal to 1 radian. Now, we're going to talk about something you did in geometry, arc length. So how long is this? Well, we know that that is part of the circumference. And circumference is 2 pi r, but we just want a fraction of it. So we just take our angle over 360. But since we now can measure in radians, instead of 360, it's going to be out of 2 pi, because 2 pi is equivalent. We could write that over there. 360 degrees is 2 pi radians. And if we multiply this by 2 pi r, we see nicely that this cancels out, so we just have our angle times our radius. Now our sector area, and I guess I could put here that this is theta since our angle measurement is in theta to match up with the drawing there. So area, we know area is pi r squared, and we just want this area, so we would take our angle measurement over 360. But once again in radians, it's still pi r squared, but it would be our angle measurement over 2 pi. Pi divided by pi is 1, so we have theta over 2 times r squared. Now, converting back and forth, changing to degrees to radians, we're going to use kind of like what you did in chemistry, I believe. So if we have 215 degrees, it's kind of like we're going to multiply by the number 1, but we're going to do radians in degrees. So we will have our fraction here. We want to get rid of degrees, so we'll put that on the bottom. And we know the equivalent is pi radians. So if we plug that into our calculator, 215, and I'm going to leave it in terms of pi, so divided by 180, so 43 pi over 36. And now if we do this next one, 5 pi over 8, once again we'll kind of multiply it by the number 1, but we want our radians gone, so pi times 180, because that's like the number 1, you could think of it. So now we have 5 times 180 divided by 8, 112.5 degrees. Now we're going to go back to that unit circle that we worked on quite a bit the other day. Whoops, see if we can. And we're going to talk about some of those important measurements on the unit circle, and we're going to look at it two different ways. So 180 degrees is pi, and a next easy one will be, what would 90 be? Well, that's 180 over 2, so that would be pi over 2. What about 45? Well, that's 180 divided by 4, so this is pi over 4. 60, 180 divided by 3, so that's pi over 3. And 30, 180 divided by 6, so that's pi over 6. Or you could think about it visually as well. So if we take a look at, and we're going to look at all our unit circle values here, here's pi, so this has to be pi over 2. Well, if we look at this top half, 1, 2, 3, 4, so this is pi over 4. You might say, well, this is really 2 pi over 4, which reduces down. We got 3 pi over 4, and 4 pi over 4, which is pi, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. And then we can go back and reduce some of these down. Well, this is 2 pi, which we knew from before. And 6 pi over 4 reduces down to 3 pi over 2. This next one here, we're going to look at the 30 degrees. So again, if this is pi, if we look at this top half, 1, 2, 3, 4, 5, 6. So this would be pi over 6, 2 pi over 6, which is pi over 3. 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. And then we go back and we reduce some of these down. So we have 2 pi, pi over 2, 2 pi over 3, 4 pi over 3, this would be 3 pi over 2, 5 pi over 3. Alright, so let's take a look at this final part that we're going to look at here. So we're going to evaluate some of these, and I'm going to show you the shortcut that I do. I like to turn these into degrees. So when I look at this, I think about, where is this? Well, this is 180 over 6, so I think 180 over 6 is 30. So 11 times 30, so that's 330. So that's right here, so we got 30 degrees. Make our right triangle, hypotenuse is 1, opposite 30 is half, negative. Adjacent, square root of 3 over 2. So cosine a over h, square root of 3 over 2 over 1. So we have root 3 over 2. So again, I always just circle this pi over 3. 180 over 3 is 60. So 2 times 60. So we have 120. So right here. Well, reference angle's got to be 60. So 1 root 3 over 2. So it would be negative half. Tangent, opposite over adjacent. So we have negative root 3. And then this next one, pi over 2. So 180 over 2 is 90. So right here, well, that's 0, 1. And sine, well, let's see. If we were to draw x, y, and 1, sine, opposite over hypotenuse, so y over 1, so it's just our y value, so that would be 1. Now the last two that we're going to look at, find the arc length and sector area of a central angle given the radius. So length, spell that right, that's dealing with circumference, so 2 pi r, but it's not the whole thing, it's just our angle over 360. So we'd have 128 over 360 times 2 times pi times 12. And I'll leave that up to you guys to type in. And then it says area. So we know that's pi r squared, but we have our area, just part of it, so what, theta over 360. So for this one, we would have 128 over 360 times pi times 12 squared. And then I'll leave that for you to type in. Now the last one that's here, it says the diagram shows a circle with center O and a radius of 5. Find the area of the shaded region. This is supposed to be the shaded region. So to get that, we could do the sector area minus the triangle. Well, triangle area is pretty easy. That's base times height divided by 2, so 5 times 5. Oh, but we don't know that that's a right triangle, so we got to figure out the height there. All right, let's see if we can find the sector area, though. Well, it's in radians, so 1.46 over 2 pi times pi r squared. And what's our radius? That's 5. So that area is, let's see if we can get back to it, 1.46 divided by 2 times 25. So 18.25. And then we have to find the area of this triangle here. Let's see. And to do this, I just realized we haven't gone over this yet, so this would be a good problem to put into the next section. We'll be able to do this after we could finish this after day H, because we need to know something called the law of sines to do this.